Ladies and gentlemen, welcome again to the Sun Hung Kai Properties Nobel Laureates Distinguished Lectures. Without further delay, may I first invite Professor Liu Pa-Wai, Pro-Vice-Chancellor and Professor of Economics, to deliver his opening remarks and introduce our next distinguished speaker, Professor Eric Maskin. Professor Liu, please.
Distinguished guests, colleagues, students, ladies and gentlemen, welcome back to the Sun Hung Kai Properties Nobel Laureates Distinguished Lecture Series. This lecture series is an integral part of the university's service to the Hong Kong community and the world of learning. As organizers of the lecture series, Sun Hung Kai Properties and the Chinese University of Hong Kong hope that these lectures will develop a global perspective in Hong Kong's academia and business and enhance its status as an international city. We are very grateful to Dr. Raymond Kwok and the Sun Hung Kai Properties for the generosity and support which make possible the lecture series. Besides the full house at the lecture theater this evening, the lecture is also broadcast live via the internet to our local sister institutions and a number of universities on the mainland. Earlier today, Professor Li He took you to the frontiers of neuroscience research. Our next guest will plunge you into the complex yet fascinating realm of mechanism design theory. It is my great honor and privilege to introduce to you Professor Eric Maskin, winner of the 2007 Nobel Memorial Prize in Economic Sciences. Born in New York City in 1950, Professor Eric Maskin received his AB degree in mathematics and his AM and PhD degree in applied mathematics from Harvard University. He just told me that he learned economics on his own when he was a graduate student from Professor Kenneth Farrell, who was his teacher. He taught at MIT and became a full professor in 1981, just 5 years after his PhD degree. In 1985, he moved to Harvard University and became the Louis Berkman Professor of Economics in 1997. Professor Maskin is currently Albert Hirschman Professor of Social Science at the Institute for Advanced Study at Princeton. He is a fellow of the American Academy of Arts and Sciences and a fellow and former president of the Econometric Society. Professor Eric Maskin's work in economic theory has had a deep influence on many areas of economics, political science, and law. His contributions range from optimal auction theory, the economics of monopoly, game theory, to mechanism design. In economics, many transactions do not take place in the open competitive markets, but within firms, in bargaining between individuals or interest groups under different institutional arrangements. Mechanism design is the study of designing rules of a system to achieve a specific outcome, when agents are self-interested and may use their private information to further their own interests. This is done by setting up a structure in which agents have an incentive to behave according to the rules. The resulting mechanism is then set to implement the design outcomes. While highly abstract and mathematical, mechanism design theory has many concrete applications in the real world. Problems such as how to design auctions, devise voting procedures, raise taxes, regulate monopolies, even assign interns to hospitals, allocate electricity and healthcare can all be thought of as mechanism design problems. The theory and method developed by Professor Maskin help us to design the best solutions, in principle at least, to all of these problems. Today, mechanism design theory plays a central role in many areas of economics and parts of political science. For his work in laying the foundation of mechanism design theory, he was awarded the 2007 Nobel Memorial Prize in Economic Sciences, together with Leonard Hurwitz and Roger Myerson. Ladies and gentlemen, please join me in welcoming Professor Eric Maskin, who will speak on mechanism design, how to implement social goals.
First, let me make sure the microphone is working. You can hear me in the back. I would very much like to express my appreciation for the invitation to speak here today. It's a pleasure and an honor to participate in this very distinguished lecture series. And I thought it would be appropriate on this occasion to talk about mechanism design since it's figured so prominently in my career. Let me just begin with another restatement of what the theory is supposed to do, and then I'll give you some examples. And I think the best way to see what the theory is about is to look at some rather concrete examples. But one way of defining the theory is to think of it as the engineering part of economic theory. Often what we try to do in economic theory is to take given economic institutions and try to understand what kinds of outcomes they give rise to. And we can do this either prospectively, that is, try to make predictions about what will happen, or look backwards and try to understand why what did happen happened in that particular way. So this is the positive or the predictive part of economics. What mechanism design does is, in a sense, just the opposite. That is, we start with the outcomes that we want, the goals, and then we ask, how can we get there? That is, what sorts of institutions or procedures, more generally, what kinds of mechanisms could we design that would achieve those goals? And so if we establish that it's possible to construct such mechanisms, then we want to know what form those mechanisms take. And this is the normative or prescriptive part of economic theory, and it's the part of economic theory that has interested me the most throughout my career. So let's take a few examples, and I have 3 examples today to go through with you. I'll begin with something which is quite possibly familiar to you from your own experience. Imagine that you're a parent, a mother, you've got a cake, and you've got 2 kids, and we'll call them Bob and Charlie. You want to divide the cake between the 2 children. But of course, it's very important to make sure that each boy is happy with the piece that he gets. That is, Bob should think that he gets at least half, and Charlie should think that he gets at least half. So in other words, what the mother wants to achieve is what we would call fair division. Now, how can we achieve fair division? Well, if the mother knows exactly how the boys view the cake, then there's a simple way of achieving fair division. What she can do is to simply divide the cake in half equally, according to her interpretation of what an equal split would be, and give each boy a portion. And because she knows that the boys see the cake the same way she does, she knows that that they will be happy with this division. The problem is, what if Bob doesn't see the cake the same way as his mother? So in that case, it's quite possible that she will think that she's divided equally, but he thinks that he's been shortchanged. He thinks that the piece that he's got is smaller than Charlie's. So this I would suggest is the typical problem that parents face, that they don't see these division problems the same way as their kids do. The mother wants to achieve a fair division, but she doesn't really have enough information to do this on her own because she doesn't know how Bob is going to view things. She doesn't know how Charlie is going to view things. In other words, she doesn't know which division is actually fair. Well, how do we solve this problem? Does there exist a mechanism or procedure which will result in a fair division, even though she herself doesn't know what a fair division consists of? And the answer, as probably many of you know, is yes. In fact, this is a problem which goes back thousands of years. You can read about it in the Bible. Lot and Abraham were interested in such a fair division problem. They wanted to divide grazing land between themselves, and they proposed exactly the solution that I'm going to tell you about now. The idea is to have one of the boys, say Bob, divide the cake in two, and to have the other boy, Charlie, choose whichever of the two pieces he wants. Now, why does this work? It works because Bob will think to himself, I'd better divide the pieces so that they are equal, because if they're unequal, Charlie's going to take the bigger one. So Bob will divide them so that they're equal. That means that Bob is going to be happy with whichever piece he gets because they're the same as far as he's concerned. Furthermore, Charlie's going to be happy because he gets to choose whichever piece he thinks is bigger. So this simple method of divide and choose solves the fair division problem. This is an example of a mechanism which achieves a social goal, in this case, fair division. And by the way, although I've talked about fair division for just 2 boys, there is a very nice extension of this method to any number of individuals who want a share of cake. And although I'm not going to talk about it now, if any of you care to ask about it later, say in the question and answer session, I'd be happy to go into it then. Okay, so this is a very domestic example of mechanism design in action. Let's look at a larger scale problem and an actual problem that has arisen in many countries in recent years. One of the things that many governments have done over the last dozen years or so is to sell off the rights to broadcast on bands of radio frequencies to private companies, private telecommunication companies. And the goal of the government in this case is to ensure that the license to broadcast ends up in the hands of the company that values it the most. But this is what is called the goal of efficiency, or efficient allocation. The reason why the government wants to put it in the hands of the company that values it the most is because then it's most likely to be used for the most valuable social purpose. The problem is that the government doesn't know which company values it the most, and so it doesn't know in advance what the best outcome is. Now, one way the government could proceed is simply to ask each company, how much do you value this license? The problem is that if a company is asked this question and understands that the company quoting the highest number is most likely to get the license, it has an incentive to overstate or exaggerate the value that it puts on the license, because that will increase the chance that it gets the license. So this naive procedure of simply asking how much do you value the license is not likely to work very well, particularly if the license is worth many millions of dollars or even billions of dollars, as they often are in practice. So this naive method will not work. Well, let's look at something slightly more sophisticated. What the government could do is to have each company make a bid for the license and award the license to the high bidder and have the high bidder pay that bid. This is clearly going to eliminate the incentive to overstate. If the license is worth $10 million to you, you're not going to bid $15 million, because if you did bid $15 million and you won, you'd be overpaying. You'd be paying $5 million more than it's worth to you. Unfortunately, the mechanism still won't work in identifying the bidder with the highest value, because now companies have an incentive to understate. Let me explain why. So suppose that you're a company named Telemax and the license is worth $10 million to you. Well, if you actually bid $10 million, which is your true value, and you won, you would get a net payoff of 0, because you'd be receiving something worth $10 million, but you'd be paying $10 million. So on balance, you would be getting nothing. That means that if you are participating in this bidding procedure, you're going to understate. You're definitely going to bid less than $10 million. But if all of the companies are bidding less than their true values, again, there's no guarantee that the winner will be the one who values it the most, because perhaps the company with the highest value will be understating by a lot, and therefore will end up not winning. So this method doesn't work either. But it turns out that there's quite an ingenious twist on this procedure, which does work. And let me show you how that goes. Let's suppose that every company makes a bid for the license, and the winner is the high bidder. But now, instead of paying its own bid, the winner pays the second highest bid. That's the twist. So, for example, if there were 3 bidders and one bid $10 million, another $8 million, and a third $5 million, the winner would be the $10 million bidder, but it would pay only $8 million, because that's the second highest. Now the question is, why does this work? Well, the first thing to see is that now a company has no incentive to understate anymore, because it's not paying its own bid. So if the 10 million company bid 9 million, it's not going to be changing its payments. If it wins, it's still going to pay 8 million, because that's the second highest bid. So it certainly doesn't gain anything from understating. And furthermore, it actually could lose by understating. It might understate by so much that it doesn't even get the license at all. If the 10 million company bid $7 million, for example, it would be outbid by someone putting in an $8 million bid, and therefore it would get nothing at all. So understating is definitely a bad idea in the second price auction. Furthermore, overstating is also a bad idea. Imagine that the $10 million company bid $12 million instead. Well, if the second highest bid is $8 million, overstating doesn't matter. The company bidding $12 million will still win. It's not going to change. It's not going to change its payment. It's still going to pay $8 million. So overstating makes no difference at all in that case. But let's imagine that the other company bid more than $10 million. Suppose the other company bid $11 million. Then the $12 million bid would win, but the company would be getting something which is only worth $10 million to it, and having to pay $11 million, which is too much. It would, in other words, by overstating, you run the risk of overpaying. And so you're not going to overstate either, and that leaves us with only one final alternative. You should bid exactly what the license is worth to you. And in fact, if every company does that, and it's in their incentive to do that, the winner will be the company that values the license the most. And so, once again, we will have achieved our social goal of, in this case, it's efficiency, getting the license into the hands of the bidder who values it the most, even though the government who is setting up this mechanism doesn't itself know which company that is. So this is the gist of mechanism design, how to achieve your goals even though you don't know exactly what the right outcome should be. Let's look at one final example, and then I will sum up. Let's consider a society with two consumers of energy. Let me call them Alice and Bob. I'm not quite sure why Bob is showing up so often, but that's all right. And there's an energy authority who is charged with choosing a public energy source which Alice and Bob will consume from. And the possibilities are either gas energy or oil or nuclear power or coal. So the Energy Authority has to pick one of these four, and only one. Technology, we'll suppose, rules out the possibility of choosing more than one. Let's imagine that there are two possibilities. I'll call them two states of the world. If state one is the actual state of the world, then in that case, we'll imagine that consumers do not put very much weight on the future. So they're much more concerned with the present than the future. In state two, by contrast, we'll imagine that they're very concerned about the future, that they weight it quite heavily. And let me suppose that the way that Alice and Bob view these four energy alternatives depends very much on which state of the world actually prevails. So, Alice, we'll suppose, is a person who cares mainly about how convenient it is to use a particular energy source. And in state 1, that will mean that she favors gas over oil. So gas is her favorite choice, then oil, then coal, and then least of all she'll like nuclear power. That's the most cumbersome to use. On the other hand, we'll imagine that she anticipates that in the future, nuclear power will become much easier to use. And so if state 2, where she puts a lot of weight on the future, is the actual state, then she puts nuclear at the top, then gas, then coal, then oil. So as I said, the reason for the difference between state 1 and state 2 is because of the technical advances that she's anticipating will occur to make nuclear power and also gas and coal easier to use. What about Bob? Well, we'll suppose that Bob cares more about safety than convenience. And that means that in state 1, he puts nuclear power first, then oil, then coal, then gas. But in state 2, he moves nuclear power down to the bottom because in state 2, he's worried about the long-term difficulty with getting rid of nuclear waste. That may not be a problem in the short run, but in the long term, he's worried about it. So just to summarize, in state 1, Alice puts gas at the top, then oil, then coal, then nuclear, and Bob has his own ranking. In state 2, the rankings for both Alice and Bob are different. Alice puts nuclear at the top, then gas, then coal, then oil, and Bob has his own ranking there too. So those are the two states. And what the Energy Authority wants to do is to choose an energy source that makes a good compromise between the two energy consumers' views. That means that in state 1, oil is going to be a good choice because notice gas doesn't make a good compromise because although Alice likes gas the most, Bob puts gas down at the bottom. And nuclear doesn't make a good compromise because although Bob likes nuclear a lot, Alice doesn't like it at all. So, and coal is worse for both of them than oil. So oil is the obvious compromise in state 1. And similarly, gas is the obvious compromise in state 2 for exactly the same reasons that oil is good in state 1. So if the authority knew which state actually was the real state, it would choose oil in state 1 and gas in state 2, but we'll suppose that the authority doesn't know the state. That's the whole problem. The authority doesn't know the state. And so it doesn't know whether oil or gas is better. Well, once again, the authority could proceed naively and simply ask Alice and Bob what the state is. They know because they know their own preferences. And what the authority could do is if they both say state 1, then the authority would choose oil. And if they both said state 2, the authority would choose gas. And if one said state 1 and the other said state 2, then the authority could flip a coin to decide whether to use oil or gas. The problem is this simple mechanism is not going to work, because notice that Alice will always say state 2, regardless of what the actual state is. She'll say state 2 because in both states, she prefers gas to oil. She prefers gas to oil here, she prefers gas to oil here, and so she always wants to increase the chance that gas will be chosen. Well, gas is chosen only in state 2, and therefore by saying state 2, she's going to raise the chance that it will be selected. Similarly, Bob always has the incentive to say state 1 because he always prefers oil to gas. He prefers oil to gas here, and he prefers oil to gas here. So regardless of the actual state, he will always say state 1, and that means that the energy authority is not going to find out what the actual state is simply by asking. He'll just get different answers from the two consumers. So that prompts the question, what can the energy authority do to make the right choice? Well, what I'd like to convince you of is that the following mechanism will work. What the authority can do is to have the consumers participate in this mechanism, which you should think of as follows. Here, Alice can either choose the top row or the bottom row, and Bob can either choose the left column or the right column, and the outcome is simply the energy source that corresponds to the two consumers' choices. So for example, if Alice chooses the bottom row and Bob chooses the left column, the outcome will be nuclear. So that's the mechanism. And I'd like to persuade you that that this will work. So let's see why it works. Well, first let's imagine that state 1 is the true state. Well, if state 1 is the true state, then if Alice expects that Bob is going to play the left column, Alice will definitely choose the top row. Why? Because if Bob is playing the left column, Alice is in effect choosing between oil and nuclear. If she chooses top, she'll get oil. If she chooses bottom, the outcome will be nuclear. And notice that in state 1, she prefers oil to nuclear, and therefore she will play the top row. Furthermore, Bob will always play the left column in state 1 because in state 1, Bob prefers oil to coal. Notice that he prefers oil to coal. And he also prefers nuclear to gas. See, nuclear is above gas. And so regardless of what Alice does, Bob is better off choosing the left column. And therefore, the outcome, we would predict that the outcome of the mechanism in state 1 will be Alice to play the top row and Bob to play the left column. In technical terms, this is what's called a Nash equilibrium. It's a situation in which neither party has the incentive to play something else, given what the other is doing. And in fact, this is the only possible Nash equilibrium. This is the only reasonable prediction about what will happen in this mechanism in state 1. But notice that if Alice plays the top strategy and Bob plays the left strategy, the outcome is oil, which is exactly what we want in state one, because oil is the good compromise. So even though the energy authority didn't know what the state was, by having the two consumers play this mechanism, at least in state one, it results in the right outcome. Now, to complete the argument, let me show you that we also get the right outcome in state two. To see that, notice that Alice is always going to play the bottom strategy, the bottom row in state two, because she prefers nuclear to oil. Notice that nuclear is above oil, and she also prefers gas to coal. See, gas is above coal. And so again, regardless of what Bob does, she's better off choosing the bottom strategy. Well, Bob, on the other hand, anticipating that Alice is going to play the bottom strategy, will play the right strategy, because by choosing the right strategy, notice that in effect he has a choice between gas and nuclear. If Alice is playing the bottom strategy, if Bob goes left, he'll get nuclear. If he goes right, he'll play gas. He'll get gas, but gas is above nuclear in his ranking, and so he'll certainly play the right strategy. So the outcome will be gas, and that's the right outcome. That's the social optimum. That's what the energy authority wants. So I've demonstrated that in either state, this little mechanism gives us exactly what the social optimum demands, exactly what the energy authority wants, even though the energy authority, the mechanism designer, doesn't know what the state is itself. And even though Alice and Bob don't care about what the energy authority is interested in. Alice and Bob are only interested in their own rankings. They don't care about the goal of achieving a good compromise. Nevertheless, in this mechanism, they will end up producing the right compromise. So we say that this mechanism, this 2x2 table, implements the designer's goals. So I've now gone through these three examples, the cake and the telecommunications and the energy examples, and in all three cases, I've shown you a simple mechanism which will achieve the particular goals that I've been looking at. But all of this may seem a little bit ad hoc. That is, each time there's a particular social goal, we somehow manage to come up with a mechanism for achieving that goal. You might ask the question, is there a general way of proceeding? That is, in a given situation with given goals, can we determine, just by looking at the goals and the basics of the problem, whether that goal is implementable or not? That is, whether there exists any mechanism that will implement that goal. And furthermore, if there is such a mechanism, we would ask the question, what form does that mechanism take? Well, it turns out that both questions, both general questions, have yes for an answer. That is, there is a general way of determining whether or not we can implement social goals. And furthermore, there is a constructive method. That is, there's an algorithm for constructing mechanisms that implement the goals at hand. So we don't have to operate in an ad hoc manner. There's a a general procedure we can follow. And that was the subject of a paper I wrote an embarrassingly long time ago. It's 30 years ago. And I'm not, don't worry, I'm not going to subject you to the analysis of that paper, but it's a fairly short paper, so those of you who are interested could have a look at it. What I'd like to point out, though, is that the potential applications of mechanism design theory are enormous. So I've just shown you three simple examples, but some of the most important questions of our time can be thought of as mechanism design questions. For example, we all know by now that not only is the planet warming up, but it's warming up because of us. That is, we're putting carbon dioxide and other greenhouse gases into the atmosphere, and that is causing the planet to get warmer. It is predicted, and there's pretty persuasive evidence for that, that this, if we continue the way we're going, that this is going to lead to fairly catastrophic climate change within this century. And so, what can we do about it? Well, because this is an international problem, that is, because one country's emissions of carbon dioxide affect the whole world, the only effective way we can proceed is to arrive at some kind of international treaty or perhaps set of treaties on carbon dioxide emissions. Of course, this has been tried already with only very limited success. Let me go back. Stick with this example. Designing a carbon dioxide emissions treaty is a problem in mechanism design, precisely because the social goal of reducing emissions, one way or another, is in potential conflict with the individual goals of the countries who are signing on to the treaty. And so the whole trick, once again, just as in our examples, is how to design a mechanism to align the social goals with the individual goals. And this presumably will be done by making suitable transfers among countries in other realms, that is, realms outside of carbon emissions, to compensate, say, developing countries for making the sacrifice of carbon reductions. So CO2 emissions is clearly a mechanism design problem for the future. A problem right now facing us is a credit crunch. And mechanism design, there again, has much to tell us about not only how to deal with the current credit crunch, but how we might reduce the risk that this sort of thing will happen again. That is, what steps can the government or governments take to prevent the loss of confidence among lending institutions that we've seen in the last few months. Well, those are just a couple of the problems which I'm looking forward to seeing mechanism design theory applied to in the future. But for now, I would just like to thank you for your attention and open up the floor to questions. Thanks very much.
Thank you, Professor Maskin, for sharing your insights with us. Professor Maskin has kindly agreed to take a few questions from the floor. If you would like to raise any questions, please raise your hands. Our staff will pass you a microphone. Now, may I invite Professor Liu Wai to moderate the question and answer session. Professor Liu, please.
Thank you, Professor Maskin, for a very inspiring lecture. And also thank you for sparing us with the mathematics. The floor is now open to questions. And please identify yourself before you speak. Yes, this gentleman here.
Professor, thanks very much for an inspiring talk. My name is Ewart Thomas. I'm visiting from Stanford University in psychology. I couldn't help noticing at the very end of the last slide the phrase presidential elections.
Oh, okay, right.
Yeah. So my question is, we've heard that the Democrats are defeating themselves by fighting within themselves between Mr. Obama and Mrs. Clinton. What remaining steps can be taken in the next few weeks to prevent such a catastrophe from occurring?
That's a very good question, but one for which I don't have a very good answer. But you're quite right that I had presidential elections on that last slide. I thought in the interest of time I wouldn't talk about it, but since you raised the question, let me say what I had in mind there. I wasn't thinking so much about the current race for the Democratic nomination in the United States, but rather the more recurrent problem that not just American politics, but politics in many other countries has faced in recent years, in which spoiler candidates have ended up changing the outcome of the election. I don't know how many people in this audience are familiar with the 2000 U.S. presidential election, but what happened there was that there were two leading candidates for the presidency, George W. Bush, who ended up winning, and Al Gore, the Democratic candidate, and everything came down to the state of Florida. The United States has this peculiar electoral college system where, in effect, there's a contest in each of the 50 states, and it turned out that the other states went into the Bush camp or the Gore camp in such a way that the whole election turned on what happened in the state of Florida. It turned out that there was a third candidate in the race, Ralph Nader, who Americans remember, perhaps non-Americans have never heard of, but it was actually Ralph Nader who ended up changing the outcome of that election, because the gap between Bush and Gore was very, very small. It was fewer than 1,000 votes. It was actually just something over 500, which is an astounding outcome in a state with almost 6 million people to have a narrow gap like that. But actually the gap was not nearly as small as it seemed, because almost 100,000 people in the state of Florida voted for Nader. And in fact, if you asked Nader voters, whom would you choose, Bush or Gore, if you had to choose between them, almost all of them would have voted for Gore. So in fact, by voting for Nader, these voters were giving the election to Bush, which seems perverse, because they didn't want Bush, but they got him. And the whole world got him. That seems, there seems something wrong with a political system where a candidate like Ralph Nader can change everything because, well, Nader got 100,000 votes, but again, that was tiny compared to the 6 million votes that were cast overall. And so that last item on the last slide was my suggestion that actually there is a better way than the American system for electing presidents. By the way, France in recent history has run into exactly the same problem. In the 2002 election, this involved Jacques Chirac, Lionel Jospin, and Jean-Marie Le Pen. Le Pen ended up changing the outcome of the election, even though he, like Ralph Nader, was more or less a fringe candidate. So this is not a uniquely American problem by any means. It's happened in many places around the world. But thank you for prompting the discussion of elections.
Yes, other questions?
Thank you for the lecture. It's really great, even though I'm not an economy department student, but I understand a lot. Anyway, I might raising a very silly question, so please correct me if I am wrong. When you're in your example on the energy source, Alice and Bob, and I noticed that Bob take the right strategy, right, in state 2, right strategy. And if he takes the right strategy, the condition is that he knows what Alice is going to choose, or he knows what is the preference of Alice in state 2. So what if he doesn't know what Alice is, what the preference of Alice, and what if the the players are not so well informed?
That's right.
What happened? Thank you.
Again, that's a good question. I wanted to give you a simple example. And in this simple example, the only thing that is uncertain is what the state is, whether it's state 1 or state 2. So even the Energy Authority is uncertain only about state 1 and state 2. Now you're quite right that in a more realistic setting, Bob might be uncertain about Alice's preferences, and Alice might be uncertain about Bob's preferences. But that kind of uncertainty can be captured by introducing additional states of the world. So for each state of the world, there would be a corresponding preference. We can differentiate between states of the world according to the two energy consumers' preferences. Of course, if we did that, the mechanism that would implement the social goals would be correspondingly more complicated. But that's okay. We can certainly take into account the kind of uncertainty that you're talking about by making use of a more elaborate mechanism.
Yeah, Professor Yang.
I'm Dennis Yang from Economics Department. Economics is so specialized these days. So this is actually my first class of mechanism design. So I'm asking as a student and not having done my first homework there. So my question is concerning the question 1 and question 2, the example 1, example 2. In the example 1, suppose the two children are different. So the first one is 100 pounds, but the second is 200. Right? So there's an initial difference in the endowment there. Also, probably the two children may also perceive differently about the fair allocation. The first one is thinking that, okay, you're twice as heavier than I am, but probably you deserve a 50% increase rather than 100%. But the second kid may think differently. If I'm twice as heavier than you, and I think I deserve 2/3 of the pie rather than 1/2. So if you introduce different preferences or judgment on what they perceive as fairness, or introduce differences in the initial conditions of the two, I was wondering whether there's still general solutions to, I think the Bible example would not work. I'm working slowly on this. Probably the Bible solution will not provide a fair allocation commonly perceived by the two. So I was wondering about how to incorporate those conditions. For the third example, I might not understand completely there also is that because the different cells to put into the Nash 4 cells is tricky. They have to be placed right. So if the authority doesn't know the preferences of the individuals or uncertain about their preferences, is there any general rules to design the position allocation of the choices into the cells so that they can induce optimal social outcome? So those are the
Okay. So on the first question, actually your first question I think was a two-part question. You were saying, first, what if the goal was not equal division, but rather giving more to the lighter boy, because, or maybe giving more to the heavier boy? Could we design a mechanism in that case so that it went 2/3, 1/3 instead of 50/50? And the answer to that question is no. That is, it's important that that this be a 50-50 split. You simply cannot implement 2/3, 1/3 unless the authority, the mother, can do this unilaterally, and furthermore, the boys agree with her judgment about what 1/3, 2/3 is. But then you were also asking, what if the boys themselves had different views about fairness? That's saying, suppose that there are, that's equivalent to saying, suppose that there are multiple social goals to be implemented. Now, in general, that's going to be a problem too. Mechanism design usually starts with the premise that we know what the goal is. It's just how to get there. That's the problem. You're asking an additional problem. What if there's even disagreement on the goal? We don't even know we don't even know the principles by which we're selecting. Well, then we're really in trouble. And I don't have an answer. I don't have an answer for that case. I mean, that's where bargaining comes in. We presumably negotiate what goal we end up following. But then you asked, well, then you asked about the third example. What if the authority doesn't know Alice and Bob's preferences? Well, in fact, the authority doesn't know Alice and Bob's preferences because the authority doesn't know what the states are. So we've already seen an example where the authority does not know what the preferences are, and yet even so, there's a mechanism that will that will get us there. As the previous questioner asked, we can make the example more elaborate so that Alice doesn't know Bob's preferences and Bob doesn't know Alice's. That doesn't change the problem in a fundamental way. That introduces more states, but once again, if there exists, there may not, if we make the example more elaborate, there may no longer be a mechanism. that implements the social goal. It all depends on the nature of the uncertainty. However, if there does exist a mechanism, the paper I was telling you about before will give you the answer. So if there is a solution, we know how to find it, and furthermore, we also know how to determine whether or not there is a solution. So that isn't to say everything can be implemented, far from it, but at least we know what can be and what can't be.
We are given a bonus of one more question, Professor Jiang.
Yeah, I'm a professor in the Department of Economics, but this is also, unfortunately and fortunately, the first lesson on mechanism design. The three examples you gave seem to have the common feature that there is a sort of government or social planner, and then you design a social goal for private agents and so on. Does the theory mechanism design apply to just two parties who have conflicting goals, say CEO versus stockholders,
Yeah.
and university versus trying to recruit new star professor, and how to make the offer, how to review the preference, and how to make a realistic yet not to overpay him. So, yeah.
Now, you raise a very good point. You would get the impression from the examples I gave that the mechanism designer is always some third party, like a government or an authority, who is imposing its mechanism on the players involved, Bob and Charlie, or Alice and Bob. But in fact, you can think of mechanisms as being chosen by the parties themselves. You gave some examples. An example I like to give is that of a house buyer and a house builder. So say I want to build a house, and you're a builder of houses. So I want you to build a house for me. But that's a complicated business, because lots of details have to be specified. You don't know exactly what you don't know exactly what I want. I don't exactly know how much things are going to cost for you to provide them. How do we handle that? Okay, that's one. Yes, I chose this example for a reason. The standard way of solving the problem is through a contract. A contract is a mechanism in which specifies what the builder is supposed to do, how the various details about the house are going to be resolved. Typically specifies a procedure by which details are specified or changed if necessary in the future, and also specifies what the buyer's responsibilities are, when payments are supposed to be made, if there's going to be a penalty clause where the buyer pays less if the seller doesn't do something on time. All of that is written into the contract if it's done well. So mechanism design definitely applies to design amongst the parties themselves.
Yeah. Well, in fact, there are a lot of applications. Shareholders and CEO, the standard mechanism is options and bonuses, whereby shareholders motivate the CEO to work hard for the company. It is a simple mechanism. But there are a lot of those, and we use some of them in our funding allocation too. Well, thank you, Professor Eric Maskin, for his insightful lecture.
Thank you, Professor Maskin and Professor Liu. Would Professor Maskin please remain on stage? To show our appreciation, may I invite Mr. Michael Wong, Executive Director of Sun Hung Kai Properties, to present a souvenir to Professor Maskin. Gentlemen, please. On this memorable occasion, may I invite Professor Liu Pat Wai to join in this group photo.